What is up, guys? I hope you are good. It's just been a busy week. Anyways, I've got with me here a PlayStation 5 for repair. So I've got two actually. I've got this PlayStation 5 and I've got this other PlayStation 5. So this one is not displaying, of which I've changed the HDMI port, but still I'm getting a display, but the display is a bit hazy. So I'm suspecting that the HDMI controller is also faulty because the pins were broken and shorted out. So I'm pretty sure it has to do with that, but I'll first confirm before I do that. I think I have a donor board that I can remove the display chip from. Anyways, this one on the other hand, it's dead, no life at all. So I was actually working on that deal which says AC adapter not installed. I think I'll make a video on about that because it's a bit of a tricky situation. I've been finding shorts. Like, I think I've removed 3 components that were causing short circuits along the PSID circuit, and now I don't have a short, but still it says unknown AC adapter. So here with this PlayStation 5, I've plugged it to the figure 8 over there. We'll press the power button and there is no response, none whatsoever. This thing is completely dead. So I'm gonna disassemble this console and then I will continue from there. Okay, so I've got the console open now. It actually took me a bit of time because I'm not the one that usually opens these things, so I've kind of lost touch. And that is my brother's job, who sits on that desk. As you see, there's a lot of stuff open there, a lot of bags. When he opens, he put those open devices in the bags. Anyways, here's a console. So this is the power supply for the console. Yeah, I'm just gonna plug the power supply and check if we are getting our 12 volts. So that is not supposed to be a difficult thing to do. Yeah. Don't mind the mess. I didn't take the time to prepare my desk for a video. I just continued with work. So here's the power supply and I've plugged it in. So what we're gonna do is we're gonna check for voltage there. So it's pretty simple and straightforward, unlike the Xbox power supplies. And we've got nothing here. We have got nothing at all. So as I was saying, unlike the Xbox power supplies, they've got the 12 volts and then they've got another separate connector with 4 pins, some of them having 5. That connector is the one that generates, that produces the 5 volts, the standby, and AC detect. So if those circuits are not working, you don't get your 5 volts. You don't get your 12 volts. So you don't immediately get the 12 volts with those consoles. Anyways, so if you check with this one, we do get 12.1 volts. So this is from that console with the display issue. So most people, they would say just swap out the console, just swap out the power supply. I can't do that. Reason being, connector is over here, connector is over there, so the two are not the same. I'm just gonna grab another console, which I have. I believe I do have another PS5 for parts, the one that I was saying I have a donor port. Let me check its power supply. It should be the same. I'm gonna pause and check it out. So this is the second power supply. So I just dropped this antenna from it. This is the third power supply actually from my donor console. Unfortunately, I can't use this one as well because it's the same as the first one. So they've got their 12 volts pin on the corner, whereas the one that we're fixing has got the 12 volt pin at the center. So again, if I measure on this, I'm getting 12 volts over there. So this power supply is dead. So what's the best way? The best way is to just get a power supply, fit it in, and you're good to go. But that is one way of killing a cat. Since we are a repair place, a repair shop, we are actually supposed to repair the faulty power supply. So I'm gonna try to open this now. Not try, I'm gonna open it actually. Now this is small. Let me use that. I'm gonna open this power supply and check it out on the inside, because number one, I obviously don't have the same power supply as this, and number two, for the sake of a proper repair, I have to open up this thing and see what's happening on the inside. I'm just hoping it's a dead fuse. Yeah, which is almost never. You don't get a dead fuse out of nowhere. Something would have killed it. I'm still trying to figure out a way to pop it open without cracking it. It does feel like it's got some clips inside. Okay, I think I found my way. All I have to do now is navigate. Okay, there we go. This is a really small prying tool though. If I had a bigger one, this shouldn't be that difficult. Which I do have, but I have no idea where it is. Because like I said, I don't open a lot. It's supposed to be with my brother though. But I do have my own tools as well. So right in front of me there is a set and another set and another set. I think I've got like 4 sets here on my desk of screwdrivers, prying tools, blades, you name it. One problem I'm having though as of recent is a problem with my soldering irons. So as mentioned before, nowadays I'm using the Powersupply 702A as a water station, and as well as what do you call it, as well as my soldering iron. But for some reason I've changed 8 soldering irons in the past I think in the past 2 weeks. 8 soldering irons, and they cost. So I'm just gonna check if there is any voltage inside the reservoirs. I don't want to be jumping around here. Okay, there's nothing, so I can touch this. Fine. So we'll go to beep mode and check the fuse. That's the first place anyways. So the easiest way to do a repair, really, it depends actually. If it's a short circuit, you would find the short, isolate the short, and then work in reverse, or work towards the cause. Whereas with the power supply, if it's dead like this, same like a dead laptop, you actually work from where the power comes in. So since this is a power supply, our power comes from the figure 8 AC connector there through a fuse which is dead, and it's written TBA H250V. So I believe it clearly says it should be a 250 volts fuse. So we do not have a beep on the fuse over there. Okay, as we continue, I think you can see some smoke there. Is that smoke or just dust? Right over there. But there's transistors, I'm not so sure. Generally the power supply doesn't have any smoke on it at the back. Not that I can see. I try to pull closer. So I'm still waiting for my microscope to come from China. Yeah, I'm I'm supposed to buy the one on Northridge Fix. That microscope camera is good. It's really good. If you look at Northridge Fix videos, they are clear. So these are coils and they seem to be fine. You know, the moment I'm just probing around, trying to figure out my way. So yeah, cool. With the dead fuse over here, we're gonna check the bridge rectifier. So from our fuse, power goes to the rectifier. From the rectifier, we convert it to DC. So all the way from the rectifier here to wherever it's going, it's now DC. So our rectifier is basically over here. So this should be our AC in. We don't have a short. Our DC out here has got a short on the bridge rectifier. So do we have any short with the middle diodes? Because remember, a bridge rectifier is just 4 diodes. So our short is on the output, which means if I come and measure by the reservoir over here, the cap. Oh, funny, I'm not getting a short. I expected to get a short over there. Simply means the power, before it gets to the rectifier, it goes through something. Oh, before it gets to the reservoirs. Okay, so I can clearly see a crack here. I don't know if I'm that good. I'm just joking, guys. Okay, yeah, right over there. Do you see the crack? There. There's a crack over there. And that crack, even it extends a little bit inside. So okay, I'm gonna remove that baby, because I don't believe that's a coil, of which if you measure here, so across the reservoir capacitors there's nothing, but here we do get a beep and a 3 ohm resistance. So I'm gonna remove that guy over there, see if our short around the bridge rectifier disappears. But I'm pretty sure the bridge rectifier is also dead, because remember, whatever happens, it hits as a chain reaction going back. So I'm pretty sure our bridge rectifier died and then our fuse died, so that your AC doesn't trip. Okay, I'm not sure if I'm removing the correct component. No, I'm not removing the correct component. Oh, as I pulled it out, it actually cracked. So now I've got 2 pieces. It's 202 RF5 235. So I'll probably be able to get that. Anyways, for now, let me check if my short has disappeared around the bridge rectifier. Oh, look at that. The short is gone. How amazing is that? Okay, so we will replace that component and hope for the best. So the one that I was actually removing was this. I honestly have no idea what it is. I believe it's a filter capacitor or something like that. Yeah, I believe it is. Let me put it back and measure if the short is there, because I also removed that, so probably the short, it's possible that the short also came from there. And as we don't have a short anymore, and we don't have a beep across this one, so the beep was being caused by the dead, I believe it's a cap. Yeah, I'm not so sure what these are. They're resistors or capacitors, I'm not so sure. 2R2 R5, probably a resistor or something. Let me check on Copilot. What does Copilot say? So yeah, you'd notice that I'm not so educated when it comes to terminology and components and the likes. I didn't actually do electronics higher than high school. So it says what? SCK 202 R5 202 R5, enter. What does Copilot say? Huh. Says the mysterious did this have to actually say okay, it says the mysterious SCK202R5, let's unveil its secrets, shall we? And with an emoji. Wow. It's a powerful thermistor designed specifically to limit inrush current when devices are powered on. They can draw a surge of current initially, which can stress components and cause issues. These little thermistors step in like the superheroes of the electronics world, taming the initial current surge and ensuring a smooth startup. Then it gives you datasheet options, all that. Yeah. So it's a thermostat. Now I know. Let me grab one from another power supply. I'll be back shortly. I'm gonna pause because I don't want the video to be long. Okay, so I'm gonna resume. Now I'm getting a lot of calls actually while I'm doing this. Okay, yeah, the video is continuing. Anyways, I've got a PlayStation 3 power supply over here, so I'm gonna grab a fuse from here as well as a thermistor right over there. You see, now I know the term, so I'm gonna use it. Anyways, yeah, let's do that and finish off this repair. I am hoping that's all we have to deal with, and I can make a quick buck out of this. So if you notice, I'm not playing music in the background. It's actually a response to what most people have complained about on the previous videos. They say they can't hear me clearly because of the music. Anyways, the reason why I played music is that I'll be recording from different devices. So I'll probably be recording from like 3 or 4 cameras, as well as the desktop screen capturing and also recording from the cameras on the desktop. So the issue that I face is that if I'm just using my voice, some of the cameras do not pick up my voice. They're like a bit far away from me because I'm not in the mode to be like speaking out loud. So because of that, when I'm now rendering the videos, trying to compile them into one clip, simply I can't get audio from some of the devices, from some of the cameras. Let me just grab something to yank this out. So because of that, I have to play music because it will be picked by every device. So the desktop will be picking it up from the fact that it's actually screen capturing the OBS or something like that. So the audio will be there, and then the rest of the cameras, they are detecting that audio from the speaker. So my hope was that actually in the first videos I used to have a mic coming from my phone or something, coming straight to my ear, hanging from my ear straight to my lips. So it would pick the sound from my voice while I'm also playing the music in the background. So the music would render the videos all in one. Like it would allow all the videos to be easily renderable without actually trying to pinpoint where I was on each. So I believe this is also a thermistor PS. I'm gonna search this one now. I believe it's a thermistor, but I'm just gonna do it. PSI. Is it PSI or PS1? PSI 05K. What does it say it is? It's actually a transducer, so I don't think I can use this. This is not a thermistor. It probably does the same thing because it's also after the. It is also after the bridge rectifier, because these are clearly thermistors, but they are smaller. Let me just grab a proper component and not something that I'm guessing is the one. Okay, so here I am, having already noticed that on a PS3 and PS4 I don't have. I went straight to the place that I know I'm gonna get components for a power supply. Like you could hardly ever go wrong when you're looking for components for a power supply. Just go and look for them on a desktop power supply. Those guys are rich. Either you do that or you go check by a power inverter. Yeah, especially hybrid inverters that also act as chargers. Yeah, those they can do. They've got everything. So here we are, SCK202R5. So it's exactly the same as the previous, as the dead one. I'm gonna check a shot across that because that power supply actually has got smoke. It's dead. Let me grab another one. Let me grab another one. Okay, so I don't have actually this component anywhere at all. So after doing a bit of research using Copilot, I figured out that a thermistor is a temperature measurement transducer. So these are one and the same thing basically. So because number one, when I picked it up from the PS3 console, from the PS3 power supply, I picked it up based on application. So it comes right after the bridge rectifier, same as here with the PS4, with PS5. So I believe it's the same. And one funny thing that I've noticed is that that's a dead one. This is two more from two power supplies, desktop power supplies, and they're dead. So yeah, I'm not so lucky. Anyways, I'm gonna solder this into place. I'm hoping that I'm aiming correctly down there. Let's push it down. Kind of needs pressure. There we go. So the pins have popped on the other side now. We just hit and let it solder. Okay, cool. So we'll check our shot by the bridge rectifier. So I actually had no idea. I never really studied or did any research about transducers and thermistors. I just know that thermistors are resistors that are temperature dependent. So yeah, anyways, digging deeper and diving further into it was never really something that I did. So I actually at some point I thought these are okay because finding two that are buzzing the same way doesn't make sense. But then I thought again, that one is buzzing and it's causing the bridge rectifier to buzz as well. So if I put these ones, the bridge rectifier is gonna buzz, which means they are faulty. They are not supposed to buzz. So that's how I deduced. Anyways, you can leave down in the comment section what you think about this, and if it is a wise idea to actually replace them with the one that I just put, with a transducer. So it's also possible that Copilot is naming these devices wrongly. So they are probably the same thing, but just with different, just Copilot naming them differently. Anyways, let me check my fuse once more. The fuse that I put works, and I'm gonna close this. The reason why I'm closing it is that if it explodes, let it explode away from my face. That is the whole idea behind it. Okay, gonna plug it in. Huh, there's no pop. There is no pop. Let's check the output voltage. Output voltage is still 000. Okay, probably I have to change the bridge rectifier as well. But thankfully there is no pop and there's no explosion. So what I'm gonna do is I'm gonna check if my The proper thing that I should have done really was to check with all the MOSFETs that are on the power supply to see if any of them is blown. Okay, as usual, I'm gonna start by measuring the voltage on the reservoir there, on those two huge capacitors. Now we do have voltage. Was it me or what? I think I saw some voltage over there. Oh, it's actually dropping. So which means the bridge rectifier is okay. We do have voltage coming in now. So why don't we have 12 volts? Why do we not have 12 volts? So we'll check the MOSFETs now. We do have a MOSFET over there and it's beeping. That's a dead MOSFET. We do have another one, I think, next to it. No, it's actually diodes. Yeah, and they're dead. This one is dead. This one is okay. So there's a diode right over there. It's a D63, and you can see the other one, not what it is, but there's D63 right over there. Okay, that's one down. We'll come by these MOSFETs that I was mentioning, some blackish stuff which looks a bit like smoke. There is no bars over there. There is also no bars right over there. So I'd assume that MOSFET is okay. This is also okay. What else do we have? What else do we have? So here we're fine. We've got here as well. So we'll check over there, which is these 3 pins, and we are okay. And we are okay. So I believe this diode is also dead. So now that's a bit tricky. Why did the diode die? Why did the chicken cross the road? Let me take it off from the motherboard here, and we can try to fix it. So we are trying to restore and save a 10,000 Rand console on the second-hand market, not even on the brand new market. So that's how expensive this thing is. By comparison, 10,000 Rand is like what? Yeah, I was checking the prices of PS5s. So if I'll be honest with you, I used to just give a price based on how difficult was the job for me. But then I ended up noticing that I'm really cheap, not gonna lie, compared to other technicians out there. I end up being really cheap, and my business struggles actually, because I'll be doing a lot of work, but then I don't benefit a lot. So expenses now, you know, you've got rent, you've got this and that. So yeah, I've come to a point where I have to step away from doing this as a hobby or as something that I'm just passionate about to doing it as a business. Yeah, those two are different. When you understand that part, you will understand why Northridge Fix has got a lot of policies like booking attempt, repair attempt fee. Yeah, so you can see this actually I've got only two legs or pins, if you would rather consider them that. So it's one of them, I think it was this one on the right, because the board was on the other side. So it was this one which is buzzing, and it's a diode. Anyone can tell you that a diode is not supposed to buzz like that. So we're gonna pop it off from the motherboard and replace it. So I think by now everyone knows what I'm gonna do if this fails. If this power supply fails to as a repair, I'm just gonna grab another power supply from the donor PS5 and use cables straight from here to the console, which have to be solid and thick, because remember this is a console, it's got graphic processing, and that means it draws a lot of current, and if you've got weak cables there, you are really gonna have problems. Funny. So I was right, actually. There's only one diode, D63. The other one is a MOSFET. The dead one is a MOSFET, actually. It's not a diode. How come I couldn't see the third pin? Anyways, if we go, yep, it's dead. So it's literally shorted on all 3 pins. I was just checking to see if the video was continuing, because I remember pausing it at some point. So I'm gonna remove those speeds. So we've got a dead GK25P VC. So yeah, where is that dead PS3? So this is a PS4 power supply. Yeah, and it's got quite a similar setup. That's why I actually took the... Oh, so it was PS4. No, it's PS3. I was okay in the first place. That's why I took that transducer over there, according to Copilot. You correct Copilot if it's wrong. We will sue Microsoft. Anyways, we've got a similar setup, a diode and a MOSFET over there. So this side is called D1 and FB3, or oh no, it's actually Q1 and D1. So I'm gonna... This one, the heatsink setup is kind of funny. It makes it difficult for me to remove it. Because remember, now you are trying to remove the heatsink, but it won't stand up because it's got a MOSFET on it, which is tied to it. And when you try to remove that MOSFET, it won't go out because the heatsink is tied to the ground. And if I try to remove the screws to separate the MOSFET from the heatsink, I've got this transformer over here, which is blocking my way. Anyways, let me pluck it out forcefully. I think if I use hot air, I'll be doing a better job than this, because hot air is basically gonna distribute the heat across. But if you have worked on this a lot, this is not a good PCB for hot air. Yeah, it'll bubble up. It'll bubble up like crazy. So maximum heat, maximum air. I'm gonna assist the heating using my soldering iron here. I believe everyone is molten now. Nope, there's no shortcuts, because now it's burning my hand. Let me remove this transformer and just unscrew the damn thing. So the transformer has got pins over there and there. I was kind of avoiding to lift this transformer. Okay. There we go, the transformer is out. Oh, came out easily, not right. for something that big. Anyways, unscrew this. Separate it, and then we can desolder it from the motherboard. Okay, cool. So there we go. Let's check MOSFET type K20A6U. So what I'm gonna do is I'm gonna type this in Copilot. This is actually what I do every day. Where did I put the third one? Oh, here it is. So what I do is usually I'll just type there in Copilot K20A60U. So what I usually type is, can I replace this with this? And Copilot generally will read all the data sheets and compare the specs, and it will tell you yes or no with GK25P. GK25P. Let's hear what she will say, she or he. I don't know what it is. Again, it's here. A transistor swap. Let's dive into the world of electronics components and see what we can uncover. Let's break what we know. Then it will tell you all the KA is a field effect transistor FET from Toshiba. Whereas unfortunately I don't have direct information on this specific transistor. Okay, so probably I typed a wrong model for this. Let me type it as but basically you should work, because by setup it's exactly the same. There's another number on top, 40N60M2. 60M2. Let's see what I get. Oh, there we go. So that's the number I was supposed to punch. Then I'll type, can I replace it with K20 with K20A60U. Yes, I can, says certainly. So yeah, it's cool. We can do this. Yeah, we can use this one, so it's okay. I'm gonna plug this into the motherboard and test. If I get an explosion, I will have learned a lesson not to trust AI. I should actually name this video as electronics repair using AI, because I've basically been using Copilot the entire time. And a bit of my general knowledge, because most of the decisions I've made have probably come from the influence of Copilot. Okay, there we go. we are in. To make it the same length as the other one so that I can fit the heatsink, which sits something like this, or like this. No, it's the other way around. That's why it's not sitting. Anywho, we shall find out if this works or not. Heatsink is in. Yeah, those guys. I really didn't think this video was gonna take this long. This should be a very short video and simple and straight to the point, but then it has taken a different turn. Oh, there they are. I mean, it's been 40 minutes. Wow, time flies. Okay. How would I squeeze this in? I don't think I can even use a tweezer for this. I'm trying to bring in the nut. Which one is the bolt and which one is the nut? It's this one is the nut. Low. I believe these things were pre-screwed before being brought to the motherboard, so it came as a heatsink with its diode and MOSFET. Okay. Now this one is a bit tricky because there's some sort of a shed. Haha, on first try. And yet it was the tricky one. Okay, cool. So I've replaced that and I think I am ready to test. As before, I am not powering on this thing while it's open. I am not crazy. I still want to live and make babies. I'm joking, I'm not doing that. But anyways, you get the point. So here we go. Pops and balloons. Oh, no explosion again. But we have a voltage output. Moment of truth. If this doesn't work, we will dim this power supply as a no fix. Yeah, it doesn't work. There is still no output. It probably is fixable, but now with the amount of time that I've spent on it, like 43 minutes, that's a lot of time. I need to work on other things. So what I'm gonna do is I'm gonna grab another power supply and just fit it into the console. And the console will work just fine. Since it didn't explode, I'm gonna plug it while it's open. And then we measure what we are getting and where we are getting it. So I'll come by the huge cap there. We've got nothing. Is it AC? No, it's DC. So we've got nothing coming in, guys. Nothing at all. Let's check AC. Our AC is coming from where? From here. So we've got 125. That is a weird reading. I don't have 125 volts on this building. Oh, is it here? Oh, there we go. 230 something volts. So what are we getting by the... Okay, so by the bridge rectifier we are getting 229 volts, and on the output, that's where we are not getting anything. No, but we are getting 319 volts. Okay, funny. So this 319 volts is the one that's coming like this up to here. So 319 volts. Okay, fair and fine. Which means this is my ground and that's my positive, 319 volts. Coming to this guy, we're not getting anything. So I've got an issue somewhere here. Is it possible that that transducer is the one that's giving me issues? Because I somehow don't have anything coming this side at all. Okay, I'm gonna open this power supply that's already working and steal a transducer from it, just for testing sake, just to verify if I actually have an issue with a transducer or just my bad luck with this particular power supply. And while I'm at it, if it doesn't work out, then I'll just solder the two cables coming out of this power supply straight to the console. I'll see what I can do. Okay, so let's see the setup. Setup looks pretty much the same to me. Yeah, so it's basically the same power supply, except that with this we've got an extra bunch over here, but it's one and the same. You combine this and this, you get this and this. So those two over there, oh sorry, you can't see it. Okay, there we go. So we've got this bunch and this bunch, same with this bunch, because it's like 6 caps, 10, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah, it's pretty much the same, 12 with that. Here we've got those two, and there we've got those two. We've got those two, we've got that, and those there over there. And then we've got these two over here, that's the pair that we were replacing over there. Okay, so let me test this one which is over here to see how it's actually reading, whether or not I was supposed to get a buzz. Okay, so it's this one here. Okay, so it looks like I was supposed to get a buzz. So it does look like I was supposed to get a buzz. And I was right not to get not to get a beep across the output of the bridge rectifier. So I'm gonna remove that thing I put there. So I believe it actually saved me because I had a dead MOSFET up ahead, so I would have kept on blowing something would have kept on blowing it. It's still charged. Oh. You are still charged. Are you? No, okay. It is discharged, so it's fine now. Anyways, so like I was saying, let me make sure again. It's oh shit, I didn't plug this and it's still charged as well. Reminds me of electro boom. If getting shocked was money, that guy would be rich. So it's 3.4 ohm resistance there. Okay, and when we come here, we've got a 5 ohm resistance. When we get to this one, 3. Yeah, so this is the exact same one. So I believe that short was there across the bridge rectifier. It was there, reason being the transistor was dead over here, but because I had this there, it was still present. The short was continuing straight all the way back to the, so when I removed it, I couldn't see the short which was coming from here anymore. So this one does have a lower resistance though, the one which is correct. It's got a 2 point something ohm resistance, so I'm not going to use that. I'm going to use this one, and that has got the 3.4 ohm resistance. I need to cut the pins. Okay, should be the perfect length now. So yeah, I don't know who to blame, me or AI. Okay, so I'll solder this back into place. Now at the same time, you have to remember this MOSFET I replaced with over here was not the exact same number, so we might get some funny behavior there. Okay, I've done that. Let me check that short across. It is still not present, so yeah, it didn't matter. So the issue wasn't here at all. Yeah, so the issue wasn't here at all. The issue was there in the first place. So shall we close this and test? I don't even know why my water is on. I'm wasting electricity. And we do have a problem with electricity at the moment here in this building. Yeah, we're getting power cuts. The reason being, they recently installed the pay-as-you-use. No, this is the wrong case. It kind of feels funny. Anyways, let me plug and test. Do you get a bomb? Okay, no bomb. No bomb. Do we have an output? Eureka! We have an output. we have an output. So our issue was with the MOSFET in the first place. Phew. So our issue was this guy. That was our issue. And then our issue was that I was not well informed with about this component, the thermistor. So I actually thought it connects across a circuit, but actually it connects in series. So power flows through it. It doesn't flow across it. So yeah, actually, if I was thinking properly, actually, if it was to be connected in parallel, its absence wouldn't really have mattered. Reason being, since it's across, like a capacitor, power still flows in the circuit even if the capacitor is not there. But if it's like a fuse or like an inductor which is in series, power does not flow if it's not there. So that's the situation. I replaced it with a component that connects across, so power was being cut somewhere over there. So I don't know if I should be happy or not, but I got 11.9 volts. Yeah, I wanted 12 volts, but nonetheless 11.9 should suffice. Now let's plug let's put the console in place. Power button and our blue LED. Do we need the fan though? Okay, so here we go. I'm gonna use display capture. Let me open OBS. In the meantime, I'll power it on. Ah, there we go. We do have a blue light, and the console is on. So I'm gonna open OBS now, and hope that the display works as well. Do we have? Oh, please wait. Yeah, we do. Start recording. There we go. Processing 100%. After the repair is complete, your PS5 will automatically restart repairing console. So yeah, this is fixed after 57 minutes, and my phone is burning hot. So this is OBS. You will check over there. It should pop right back up because the console did restart. Okay, give us a display. There we go. Beautiful. So this console has been fixed now. Yeah, there we go. PS5 blah 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 blah. So yeah, this has been fixed, and it was a bit of an emergency. That's why I stopped doing whatever I was doing to fix this. Reason being, tomorrow I'm not gonna be here. We're actually gonna be working on table mounting. The speakers there are not working for some reason in the mountain. I don't know what speakers for what. So we're gonna be there. Anyways, this is fixed, guys. The power supply has been fixed. The issue was with dead MOSFET and unfortunately a cracked thermistor. So the thermistor kind of gave me a wrong notion that it's dead when it probably is dead, but then yeah, it could have still worked because it's working basically as an inductor. And then there was the downside of using AI. So like I had said, what I was doing is I would search here on Copilot and then I would get result from Copilot. So yeah, that mix kind of delayed the whole thing. So this video could have really been short, like maybe 5-10 minutes tops, something like that. Anyways, I hope you enjoyed the video, guys. Like and subscribe if you enjoyed, and I will see you in another clip. Bye.